So we are starting a new unit, the Pythagorean Theorem, and this will be unit 7 on the Pythagorean Theorem. And by the end of this unit, here are your I can statements that you should be able to use, and this is the Common Core. There are a few vocabulary terms that you need to be responsible for: Pythagorean Theorem, hypotenuse and distance formula, and you will see those on the final exam. So without further ado, here we go. Lesson 7-1, the Pythagorean Theorem. We're going to find the hypotenuse first, okay? So if you were in class with me, we talked about the history behind the Pythagorean Theorem. It was created by a man with the last name of Pythagoras, and he studied different math concepts, and he figured out the Pythagorean Theorem by studying the Egyptian rope stretchers. And those people were the ones who made the Egyptian pyramids. And so he discovered that the formula for the hypotenuse works for the formula for the Pythagorean theorem works. And this is always based on a right triangle. And this is what they used to make the pyramids. And they made two right triangles. They put them together to make a square. And so if you know what the pyramids look like, they have a square base to them. And it was built on the Pythagorean theorem. So a little bit of history there for you. So they're all based on right triangles. The right triangle is a triangle with one 90-degree angle. The sum, go ahead and write that in your notes, of the angles is 180 degrees. So sum means when you add all of the angles up. All right. So this is a right triangle, and you know it's a right triangle because it has a right angle. And you can see that if you know from before, they might put a little square in there like this, and that means 90 degrees. All right. Legs. So this Pythagorean theorem is based on a couple of things called legs and hypotenuse. Legs, and I'm not talking about the two legs that you have on your body. Legs for this are the two shortest sides in the right triangle. And they are referred to A and B, so I'd put that in parentheses just so you know. And those two legs are the ones that form the right angle. So the legs form the right angle. So usually I always highlight the legs in blue. So this is a leg here, and this is a leg here. So those are both legs. The legs form the 90-degree angle, and you can see that they make up the 90-degree angle right there. So they're referred to as A and B. The legs form the right angle. All right, so moving on. Next, you know it's in a box, so you know it's going to be in the test, and that was one of the words that we talked about from the first page, and that is hypotenuse. Kind of a different word, hypotenuse. Hypotenuse is the longest side of the triangle. It is the longest side of the triangle. And it is opposite of the right angle. So it is opposite of the right angle. All right, so usually I always make the hypotenuse in orange, so I'm going to pick up orange. This, ladies and gentlemen, is the hypotenuse. You can see how I highlighted it in orange. Hypotenuse, I'm going to put it in orange. It's the longest side, and it's opposite of the right angle. So when I talk about opposite of the right angle, here's the right angle. See how it's right across from the right angle? I kind of drew a little arrow in there. Okay, so it's across from the right angle. It's also referred to as the diagonal. So sometimes you might hear, they'll say, well, what's the diagonal's length? Well, the hypotenuse is the diagonal because you can see it's kind of on a diagonal. It is also referred to as C. So you had the legs were up here, A and B. Now the hypotenuse is C. So I'm just going to draw another example in here so you can just kind of see it. So very similar to what you see up here. There's my right angle. Okay, so the hypotenuse is right across from that right angle. So here's that hypotenuse. And again, A and B, they form the right angle. Those are legs. Okay. Now, this only works for right angles. So a non-example would be something like this triangle. Because this triangle right here is the angle. That angle is what we call obtuse. So I'm going to write this in here. This is obtuse. It's not a 90-degree angle. It doesn't make a little corner edge. It's obtuse, so it's not a right angle. And the Pythagorean theorem will not work for anything that's not a right angle. So it's a right triangle. So it won't work for that. It only works for right triangles. All right, so that brings us to the big to-do. The whole entire chapter is built on the Pythagorean theorem. So that's our next definition, Pythagorean theorem. Pythagorean theorem is an equation that shows the relationship between the legs and hypotenuse of the right triangle. So it's going to show the relationship between the legs and the hypotenuse of the right triangle. Remember, it only works for right triangles. So the formula is, and you're going to know this inside, outside, backwards, forwards, a squared plus b squared equals c squared. So a squared plus b squared equals c squared. A and b are the legs, go like that, and c is the hypotenuse. So it all fits together. A squared plus b squared equals c squared. Again, we'll draw a little picture like this. And we got our right angle. And then we might have a 3. We might have a 4. And then we have an X. And so we would call this side A. Maybe I'll pick up a red here. So A, we'll call this B. And then this, of course, this X is our C. All right, so we're talking about legs. So the legs here are A and B. Those are my legs. So these are my legs right here. C is my hypotenuse. That's right here. This is C, hypotenuse, and this is C right here. So in order to calculate one of these, this is what we do. We take the formula, which is a squared plus b squared equals c squared. And we plug in what we know. Well, c is right here, and c is an x. So I'm going to replace that c with x, and then I'm just going to put squared equals. Now we got to replace a and b with the legs. So a is a leg, b is a leg. So we have one leg that's 3. We have the other leg, which is 4. So I'm going to put in a 3 and a 4. It does not matter which is which. So I do 3 squared plus 4 squared equals x squared. Now we can go ahead and solve that problem. So 3 squared is 9 plus 4 squared is 16. And you should know that from our unit 2, how to square things, equals x squared. So 9 plus 16 is 25 equals x squared. Now, if you remember from that chapter, we also talked about how to undo from unit 2. How do we undo a square? What's the opposite of squared? And if you remember, Hopefully you're saying to the screen, it's square root, Mrs. Smith, it's square root. And I would say you're exactly correct. The opposite of squared is square root. So when that happens, the squared and the square root cancel each other out and leave you with x. And then you take the square root of 25, and that is 5. So my missing x is 5. And we're going to do some more of that here in a few minutes. So there we go. Our definitions kind of get us started on Pythagorean